Hello, my name is Fatih Furkan Erkeç. In this video, we will do the Lab 5 guided lab facial recognition in Amazon Machine Learning Foundations course. And facial recognition is a common use case for machine learning. There are various packages for Jupyter Notebook that you can use for facial recognition. In this lab, we will start by using SageMaker to create Jupyter Notebook instance. We will then learn how to use Amazon Recognition to platform a facial detection of a known face. The general steps we will follow are create a collection, upload an image of a face that will be used for detection to Amazon SageMaker Jupyter Notebook, add the image to the collection, view the bounding to be created for the image, list the faces in the collection, use the collection to find the face, view the bounding box of the face, delete the collection. The objectives are, after completing this lab, we will be able to create a custom collection for Amazon Recognition, add an image to custom collection, detect known face in image, and in conclusion, let's go to our face detection notebook. Computer Vision Face Detection Lab Student Notebook. In this lab, we will use Amazon Recognition to perform a facial detection of a known face. The high-level steps we will perform in this lab are create a collection, upload an image of a face that you want to detect to the Amazon SageMaker notebook, add the image to the collection, view the bounding box that was created for the image, list the face in the collection, use the collection to find the face, view the bounding box of the face that was found, delete the collection. Importing Python packages. I ran them before, so let's start the kernel. Start by importing the Python packages that you need. In the following code, matplotlib provides plotting functions. Schemage represents scikit image, which provides several useful image manipulation tools. Boto3 represents the AWS SDK for Python Boto3, which is the Python library for AWS. NumPy represents the NumPy, which is library for manipulating data. PIL represents the Python imaging library, which contains a set of tools for drawing images. Task 1, creating a collection. In this task, we create a collection in Amazon Recognition. You only need to run this step once. I ran the cells several times, that's why I tried some different things to do in the code. So this gives error, but it runs other codes correctly. So here we client Boto3 client recognition. The collection ID is collection response. We create collection in the client, collection ID is collection underscore ID, and here's the print codes. It gives an error, but it gives that because we already create that collection, but other codes works correctly. Task 2, uploading an image to search. Use the provided sample image, which is named momjpeg, and upload it to this notebook. Then look at the image by running the cell. File name momjpeg, as we can see here. Files image io imread file image. Plot in show. We plot the image in here. Let's open that image. This is the image we want to open and plot here. Let's run this cell. As we can see, we load the image and make sure that the image size is less than 4096 pixels by 4096 pixels. If the image is larger than this size, then you must resize it by using following code: face image, rescale face image by 0.5, mode is constant. The numeric value represents the factor to scale by a value of 0.5 will scale the image to 50% of the original. When the image is resized, save the file by io.imsave file name face image. You must copy the code into a code cell and run it, but we don't need to do that because the MomJPEG is not bigger than 4096 by 4096 pixels, as we can see here. So let's run task 3. We are here, task 3, adding the image to the collection, and add the image to the collection that you created earlier. External image ID file name with open file name rb as fimage. We add the image to the collection by that code, and result for file name we should see MomJPEG here, and face indexed we could see the indexed face below that. We have a for in here to every indexed face, and print face not indexed. Indexed not indexed face in here. Let's run it. Result for MomJPEG face indexed face ID. We can see the face ID of our MomJPEG, and location with 8 left top. We see the location of the face, and face not indexed. There is no face not indexed. And viewing the bounding of the box that for the detected face. If a face was found, the results should include the location of the face that was detected. Examine the bounding box on the image. To do this, use PIL library, which you imported earlier in this lab. By extracting the bounding box, you can draw a set of lines around the image. We define an image open file name, image width, image height, and image size. Draw, we define a draw, and image draw image. For face record in response face records, we create a box and we define left top width 8 and the points here. Draw the line, points fill, and width is the width of the drawing line, and after that we plot the image with a bounding box, as we can see. Task 5, listing the faces in the collection. Examine the image that you have in the collection. Max results is 2, face count is 0, tokens true, and we print the faces in collection here. We list the face in the client here. While tokens, we have a loop here. We count the faces, and if not, next token in response we list it, else we return tokens is false. Faces in the collection, face ID, we can see the face ID, the bounding box, and image ID, external image ID, MemJPEG, which is that image, confidence, and index faces model version is 7. Finding a face by using the collection. In this step, we will use the collection to detect the face in image. Use the provided sample image that's named target JPEG and upload it to this notebook. And let's run that cell. Target file name, target JPEG, target image. We open the image by image.open target file name. Plot imshow. With this code, we plot the target JPEG in here, which is that JPEG we can see here. And let's run this cell. As we can see, we plot the target JPEG. Next call, search the face by image operation and see if you get a match. We have a threshold here, 70%. Max face is 2. With open targets file name, we open the targets and face matches response to face matches and print the matching face for face ID similarity and external image ID. Let's run this up. We found matching face. The face ID is that. The similarity is 99.91%. External image ID MemJPEG. So we found that face is similar to MemJPEG. Drawing a bounding box around the discovered face, and we here draw a bounding box to that face. In here we can see the codes of that drawing a bounding box around the discovered face. As we can see, we draw the bounding box, and here when we are finished, delete the collection. To do this, run the following cell. We deleting the collection we create in here and deleting the face from the collection. Attempting to delete collection, all done. Okay, we have completed this lab and we can now end the lab by following the lab guide's instructions. So I'm gonna end the lab. Thank you for watching. Have a nice day.